All right, this next section is about calculating the volume of a solid of revolution using washers. And I'm aware that some people's brains, when they hear the word washer, think of a washing machine, and some people's brains, when they hear washer, think of this piece of hardware. And so I want you to train your brain for today to think of washer as that piece of hardware. So when you're trying to find the volume of one of these washers, what you're doing really is finding the volume of the whole thing, and then you're going to take away the volume of the whole. So big R is the radius of the washer itself, little r is the radius of the hole, h is the thickness or the height of the washer, and so the volume would be pi times big R squared, take away pi times r squared, and then times the height. So here's pi r squared with a big R. That would be the area of the entire thing. And then you take away the whole. So anyway, what we're going to be doing today is we're going to be taking a region and spinning it around the axis. But unlike last week, our region is not going to go all the way down to the axis that we're spinning around. There's going to be a gap between our region and the axis, and that gap is going to cause a hole in our solid. And so when we slice it, we're going to slice this and create washers because there's a hole in our solid. The formula for calculating the volume of a washer is over here on the left. You do an integral from a to b, and you subtract the two radiuses, but you square them first, just like we did on the washer over here. We square the big radius minus pi times the little radius squared. Make sure you square them separately. You're not subtracting and then squaring. You're squaring first and then subtracting, because you want the entire area of the outside of the circle minus the entire area of the hole, and then times the height. All right, we're going to do an example. We're going to take this region enclosed by x equals 0, sine x and cosine x, and revolve it around the x-axis. So what's different about today from yesterday is that the shaded, or from Friday, the shaded region doesn't go all the way down to what we're spinning around. There's a gap here, and this gap, when we spin it, is going to cause a hole in our shape, and so that's what's new today. This is still calculating the volume of a solid of revolution, but for this one, it's kind of like a hollowed out bowl, this one. So like this would be solid, but there is a cutout in the middle so that we could actually put something inside of this one. If I take a sketch of just one washer, because we're spinning around the x-axis, the thickness of the washer would be dx. And the hole is caused by this curve that's closer to the x-axis, which would be sine, because I know sine starts at 0. So the hole is caused by sine of x. And the outside radius of the entire washer is caused by cosine of x. So that would be all the way from the x-axis up to that blue line would be cosine x. So if I want to calculate the integral, I'm going to start at 0, and I'm going to stop here, which is the place where sine and cosine are equal to each other for the very first time, because it's in quadrant 1. So it's going to be pi over 4. And then we're going to do pi times the big radius squared minus the little radius squared times the thickness of each washer. We are not going to solve integrals today. I'm working on just setting them up. So for example 2, we have the region in the first quadrant enclosed between x cubed and 4x, and this time we're going to spin it around the y-axis. So because the region is not shaded all the way to the y-axis, when we spin it, we're going to have a gap, and so it's going to be a cone shape that's cut out of the middle, and then a bowl shape on the outside. So each one of these washers is going to have a thickness of dy, and the distance, the inside radius is going to be the x-coordinate of the linear function, but we have the linear function is defined as y equals 4x. So if we want to talk about the x-coordinate, we would say that's y over 4. And then the outside radius is going to be the distance out from the y-axis to the cubic function. But again, we want a y-coordinate for that radius, so we're going to, we want an x-coordinate for that radius, so we're going to solve this for x. So x is going to be the cube root of y. So the outside radius is y to the 1/3. So then when we set up our volume, it's going to be the big radius squared minus the little radius squared times pi times the thickness. And then we're going to add up, starting at the bottom of our shape, the y-coordinate would be 0, and we're going to stop where the two functions cross. So we're going to stop where 4x is equal to x cubed, or not x equals 0, because that's this point, not x equals -2, because that's over here, but x equals +2. So we're going to, x equals +2, but we don't want to go to +2 because that's an x coordinate. We want this to be a y coordinate. So we're going to go to 8. Plugging 2 into either f or g, we get 8. So this point right here is 2, 8. I hope you can see that even though I talk about how we're just setting up the integrals, this is one that you could totally take an antiderivative of and it wouldn't even be that bad. You would square this, you would square this, and then you would do antiderivatives. It's not a really terrible problem. All right, so for example 3, we're going to go around this line y equals -1, which is a horizontal line. And when we do that, we have a cylinder that's kind of cut out of our vase now. So it's going to be, we're spinning this around, we have a hole that has actually a constant radius, and then we have a radius on the outside. So if I sketch this washer, it's going to be sideways, it's going to have a little thickness of dx. And the inside radius is actually just always going to be 1. The outside radius is going to be the distance from -1 all the way up to this curve. So it's going to be the y-coordinate plus another 1. So the distance here is going to be y plus 1. You can also think of it as the y-coordinate minus -1, because the y-coordinate is on top. We always subtract the taller one minus the shorter one, but since -1 is negative, it would be this y-coordinate minus -1, so y plus 1. Of course, we don't want it to be y because we have a dx, so we're going to call it 2 plus x cosine of x plus 1, or maybe 3 plus x cosine of x. And so then when we do our area, it's going to be our volume. It's going to be this big radius squared minus 1 squared times the thickness, which is dx, times pi, and then we're going to integrate x coordinates, so -2 to 2. All right, this last one, we are going to take this region enclosed between square root of x and 1/2 x, and we are going to revolve it around the line x equals 6. All right, so the when we sketch our shell, because we're going around a vertical line that's like the y-axis, we're going to have a dy thickness. So our shape goes like this. And the inside radius is caused by the line, but it's not the line. It would be the x coordinate of this thing. So let's go ahead and solve that for x. It would be the x coordinate, but not really, because it's going to be 6 minus the x coordinate. And then for the other one, again, it would be like the x coordinate, except again, it would be 6 minus the x coordinate. So the outside radius is going to be 6 minus, oh, we need that thing solved for x as well. So right now we have y equals root x, so that means that x is equal to y squared. And so our integral would be from 0, which is a y coordinate, to this intersection point, except we want the y coordinate of that intersection point. So we want to solve that. So we have 1/2 x is equal to square root of x. Or maybe, and I think this might actually be easier, y squared is equal to 2y. So y squared minus 2y is equal to 0. So y is equal to 2. So we're going from 0 to 2. This point right here is 4 comma 2. And we are doing the big radius squared, pi times, minus the little radius squared. I'm going to get myself some space here. And then times the thickness. All right. So a couple of things. One, if you're spinning around a vertical line or the y-axis, then you're going to have a dy. If you're spinning around a line that's not an axis, you're going to have to subtract to get your radiuses. You want to take the further right curve minus the further left curve, or if you're spinning the other way, the taller curve minus the shorter curve. And you're going to have to find intersection points by setting your equations equal to each other. All right, that is volume using washers.